Hello and welcome back. Thanks for joining us again on the second of Lionel's designs and taking you through creating fantasy titles. Just in case you didn't know that we have a range of topics coming up, as well as today and tomorrow to finish off the 3 sessions Lionel's doing. We have many more on the Maxon events page. So please head over to maxon.net and go to events, and you can see all the sessions that we got coming up. And so hello to you, Lionel, welcome back.
Hello, welcome, thank you.
We had some fantastic response to your session yesterday with enthusiasm, not just for what you were showing, but how you were demonstrating and leading people through. So that was really great. In fact, let's just show you here on the Maxon training site. This is where the recordings live. So you'll probably know this already, but if you wanted to watch yesterday's recording and you missed it, please head over to YouTube and look at the Maxon training team. And here is the session from yesterday, designing and compositing titles. I just wanted to also show you here in the description area, this is where the Lionel has very kindly provided these project files. So a version of what he's working on, including something where you can start and follow along, or you can look at the more completed project. So if you'd like to download that, that's where the link is. We'll add the link into the automated email that you get on these webinars too, and we'll put it in the chat window. But that's just a nice way of getting some extra insight into his method, if you like. And also, some of the links here for a couple of questions we had. Please could you post the links to Lionel's Udemy courses? And so we put them in the descriptions here as well. And these are courses where Lionel takes you through lots and lots of more of the sorts of things that he's already been sharing with you. And there are multiple courses here. So that's just really where to look for under Udemy. And there's 3 courses there, and Lionel's very kindly given a voucher for lots of money off. So thanks for that, Lionel.
You're welcome, of course.
Great. Okay, so we've got lots to get through. So let me hand over the screen to you. If I right click on here, I should be able to make you a presenter. Here we go. And if you've got any questions as we go through, Darren, another one of our master trainers, is also on the line here, and he can help by answering the questions. So just put those into the questions pod or via text. We'll answer those as we're going along. Thanks, Kent. All looking and sounding good. Bonjour to Lionel from Joel, and thanks, Pierre. Or Pierre says, always a pleasure to learn from you, and so on. So thank you for that. Quick question from Gabe, that you should be receiving an automated email after each session. All the same links are on that list for the YouTube site, but if you haven't, please let me know, training@maxon.net, and we can help you out with that. Right, I'm still sharing my screen, so I think I'll make you presenter again, Lionel.
Oh,
okay for that. Should then come through to you.
it's saying it's showing my screen, so I think it works. Is it?
There we go. Yes, it is now.
It's working. Okay, so you see the red giant logo?
Yep.
The final one. Okay, so shall I start?
Yes, please.
All right, so welcome all. And so today we have a lot to take on because I wanted to show you very quickly how to make an advanced title like that. So I'm not going to show everything about the texturing and so on because it's quite long. So I would just show the final shader. You have this shader inside the exercise file I provided yesterday, and you have the link on the YouTube channel and also here. And I'm just going to explain how the shader works, and then we'll go to the core of the subject, creating clouds using several ways, using C4D only, and also using Xparticles. And for the next session tomorrow, we will see how to integrate everything together and how to create flames also to make our logo even cooler. Okay, so this title, this is the final rendering. And as you can see, this is a complex material because we have the metal shader we created yesterday, but we also have the edgeware effect. and also some rust only on the top of our logo. You can see here the main logo, the front is intact, but you have some spots of rust on the top, and everything is procedural. That means it's being created by the software. There is no UV on this model. That's interesting because we have a lot of polygons, and it would be a bit difficult to unwrap everything, and everybody hates unwrapping. So if we can get by without unwrapping, we're all happy about that. So okay, so let's see how the shader work. So this is the final shader here. I'm just going to, so yes, it's a bit complex, not that much actually, and I will walk you through all the details here. So at first, we have here our iron material. So this is exactly the same kind of material I created yesterday with some Maxon noises for the bump and the reflection roughness, and that create the iron material. And then it's going to be piped into a metal blender. Okay, and the metal blender is the material, the shader, which is going to combine everything. Okay, so if we take a look here at our rendering, we just to hit the render to see that everything's live. Okay, so we see on the top a close-up to our title, and we can see here we have this edge wear. So the edge wear is natural phenomenon where you have your material being eroded by time, by rust, and so on. Okay, so obviously it's going to sit on the edges, everything that's convex, and we also have some spots of rust resting on the top. So you can see we have a lot of those specks here on the top of the geometry, on the edges, but we have none here on the front. That makes the metal look more realistic. So how was it done? We have our gold material. So I created, well, not really a gold material, I call it gold, but it's just a copper material. I can just show it here, hitting solo. Let's render again. So this is a very simple material created with the presets. There is no bump, nothing on it, and it has a very low roughness. So it's going to catch a lot of the highlight and so on, and to be very clear. Okay, that's going to be the material which will be seen through the edge wear. Then our gold here is piped into the metal color. You can see here. And then we have a blend color. So the blend color is actually a mask, which is going to show the gold through the iron we have here. Okay. So about the blend color we have here, we can take a look at the mask, hitting here on the solo, and this is the mask. So this is a procedural mask being created on the spot. And if we go through the flow, we can see this is a curvature effect. So the curvature is the shader which is going to guess the edges of a geometry. So this is a live shader. It depends on the geometry. And if you have something with sharp angles and so on, it's going to work quite well. And our curvature, I just feed it here with a texture. So let's see our texture, which is this one, this texture. And it's being piped into a triplanar, so we can have a nice unwrapping without having to unwrap everything. So this is our texture, our raw texture. You can see here we have only the texture without the triplanar. We don't see anything. With the triplanar, it's being mapped on the surface, and it looks good. Then we have a ramp to restrict our map here. This value here is going to allow us to change the scale overall of our scratches. So let's do it this way. And then, so the ramp is going to restrict the dynamic we can have here. The range is going to, well, it's pretty complicated to explain, but it's going to show how far the texture is going to appear through the curvature. So if I just show the change range, we can see it's just a bit brighter, and then it's going to work with the curvature. And this is the result. And then it's going to be piped into another change range to have a brighter black and white image. And at last, it's been piped into the blend color. So we have our material blender. So if I just uncheck here, we can see our material being shown through that. So obviously we could have used, instead of a texture here, another Maxon noise that works, or any other texture. The curvature is great because it's going to work with anything really. Then we have how I'd created the rest of the specks of rust on the top here. So this is a third material, obviously. So material color here. We're going to look through the material. This is here, rouille, that's rust in French. And it looks like that. So you can see it's not very complicated material. It's very rough. It has a high roughness because rust is, well, rough. And this material is going to be shown again through a blend color. So the blend color, which is a mask again, if I'm going to see the mask, this is the mask. So you can see it's only going to be shown on the top of the geometry. Why is that? Because I use here our state. So the state shader is going to give us color indicating the direction of the faces. Okay, it's very easy to see. Green is up, red is right, and so on. So I used here the green on the color splitter to have just a black and white image. So actually, I don't see much because, but this is a green we're interested in. Okay, so it's being fed into a color layer, which is just a mask. So I'm going to use some blending mode, and it's going to work with a Maxon noise, which is this one, through a color correct. And this one is the POXO, which is great for that kind of stuff. So altogether, it's going to give that. Okay, then it's going to be restricted through a ramp. And we have our spots of rust. Then it's going to be used on the displacement and inside the blend color. The one being used for the displacement is different from this one because we want to have a displacement, so it's going to actually crease the geometry. It's going to dig into the geometry. Instead of bumps, so it's going to really push the polygon. But here our color correct for the material so that the red color of the rust is not going to be exactly the same as the polygons that are being pushed. So that gives us that extra layer of realism when we add everything together. So I forgot where is my solo layer. It's this one. Okay, just uncheck it. And we have our final material. And you can see we have some nice details here only on the top. And I could change anything here. I can change my ramp to have something even narrower, or and so on and so on. So yes, I think that was a bit quick, but that's because I have a lot of other cool stuff to show you. Don't hesitate to explore that shader because you have it with the exercise file. This is actually this file, the title only RS. You have also the frost material I showed very quickly yesterday, and you can play with it and see how it works and try to see how it works. Okay, so now let's create some clouds because that's also some undertaking. because it's a bit complex. It's a bit complex, but I'll try to be as clear as possible about it. Okay, so to show you what we want to do, we want to create clouds like that, or even better, like that. Okay, so this one I think is the best, the more details. This one has been created with Xparticles. What's great with that, we can have now a generator of clouds, so we can do a lot of things with it. But with Xparticles, it's slower and more complex, more difficult to create than with the other way, this one. So the cloud is not as nice or not as detailed, but it's pretty good. And this one is pretty easy and fast to create. And this one is just going to be created with Cinema 4D and nothing else. Okay, so you can create this one with any Cinema 4D from R20 to R23 we have today. It's going to work right off the shelf. For the other one, you will need to use Xparticles. Okay, so let's see how I created this cloud. And I will go slower than with our material because we have a lot of explaining to do. I'm going to create it from scratch, okay, to show you it's easy. When you know what to do, it's easy to do it. Okay, so it's going to involve the volume builder again, but through another way. We're not going to use the sign fields, we're going to use the fog fields. So let's create a simple sphere. This sphere, I want to use as a type the icosahedron, okay? Because we have triangles and we have a very regular geometry. Actually, I don't like this one because we have these poles, complex poles here. It's pretty bad if you want to do some displacement and so on. So I always use the icosahedron, even though it has triangles. It's going to behave the right way when you're going to use some displacement and so on. Okay, so now this sphere, I want to keep it editable. So I will not transform it to editable polygon like that. I want to have it parametric. I will go to the sphere and coordinate. We're just going to increase the coordinate on X, something like that. Then on the object, we're going to add many more segments like that. Okay, I need to see everything. Also, I'm going to hide my work plane. Now we're going to create some cloud shape, obviously, using again our displacer. And the displacer, we're going to use it again a noise. Well, actually, I didn't use a noise the last time I bought the title, but I could have used a noise. So our noise, I'm going to use the default texture here, the simple noise. We're going to just increase the scale. We'll go back, and on the object, we have the height. So it's going to displace like that. So something I could do here is drag here the height here. So I can do it right here. And then if you go to the shadow noise, now I can play with the global scale, the displacement like that, and try to find the right amount of displacement, something that looks like. I think this one is nice. We have also our seed. If you want to have some different shape, actually, I prefer this one. And play here with our displacer. Okay, so that's our basic shape, and already we can do something with that. Now we need to put it inside a volume builder. So Alt to have it as a parent, and we will change the volume type from time distance field to fog. Okay, so fog is going to fill everything inside with voxels. That's why they appear as dots. With the sign distance field, actually, our voxels are empty. If we go inside our cloud, we will see some black because it's empty. All right, so the sign distance field is just the skin of voxels, whereas the fog is already filled with voxels. Our voxel size, I'm going to decrease it. Let's go to maybe 4 centimeter. I think that would be fine. Okay, so we have that. And now I can already make a render out of that. I just need to go to Redshift material. We're going to create a volume material. I'm going to apply it to the volume builder. And then here on our presets, I'm going to go to basic. And we have here our basic scattering, absorption, and emission. So we only need for creating smoke, cloud, and so on, we only need to put something inside the scattering. So we have some presets. I just click there. We see here we have volume builder, and I'm going to choose the volume builder. Okay, now I'm going to create some lighting, and for this one, I will just create the default the Redshift Sun and Sky rig. Now, if I hit render, I won't see anything because I see something. Yes, because we have it's not look very good because it's only being lit by the our sky, which act as a HDRI. And if we go here in the Redshift render settings, that's because here I have already created some settings using the GI as a brute force. If I don't use it, you see it's just pure black. So let's go to brute force, and I will use another brute force to have full fading. And it looks very dull because the sun is not contributing to the lighting. So you need to go to the sun, which is a direct light. And I need to, in the volume tab, put it to contribution scale to 1. Okay, so it still looks like crap because we are just starting. But we can see our voxels. Okay, so I'll go to the volume builder here and click on the sphere, and we have a very interesting option here. We have some inside voxel fall off and maximum voxel fall off. So to explain it very quickly, the fall off a voxel in volume is almost like a 3D gradient. Okay, and here our 3D gradient is not very smooth. If I just hit here at the maximum voxel fall off, it's going to have a fall off starting from the center of the voxel of the cube. So if I click there, we have something much more satisfying to the eye, and it's starting already to look like a cloud. Okay, but it's still very well, very wispy. It's not wispy. It's it doesn't look like a very good cloud, but we have the soft edges we wanted. Now I can play here with the shader, and it's very easy. The scattering is the light traveling through our cloud. It's almost like a diffuse. So if I increase the scatter coefficient, it's going to be more lit. Okay, easy. And we have here our absorption is the opacity of the cloud. So if I decrease the absorption, it's going to be more transparent. Because it's going to be more transparent, it's going to take more lighting. So I'm going to decrease the scatter. And I'm going to play all the time between those two values, depending on your lighting and so on. So something I could do already with our sun. I'm going to select the sun here and use the rotate tool. And we're going to bring our sun lower on the horizon. And I could even, yes, put it something here. Okay, so the cloud is, the sun is behind the cloud, but we can see it because our cloud is too opaque. So I can solve that by just lowering the absorption coefficient. And at some point, I will see the sun through it. I'm going to decrease the scatter coefficient, and you see here the sun through the cloud. So that's interesting if you want to see your sun behind the cloud. But most of the time, when the sun is behind the cloud, you don't see the sun. So we're creating a very vapory, very vague cloud this way. But that just to show you, you can have this effect by just playing here with the absorption coefficient and the scattering. Okay, so for what we're going to do, I don't want to have such transparent clouds. So I will go back here and put back some absorption and scattering to have something more opaque like that. Okay, so this is a bigger cloud. And you could call it done because it's already looking like some cartoon cloud. It's very light on the processor. You can see it's rendering pretty fast. And it's not very heavy for the computer. You can put that inside the cloner and so on. It's going to work perfectly well. Okay, but we want to create a cloud with more details. Okay, and that's going to be more difficult, but not that hard either. Okay, so I'm going to stop the rendering. And first thing first, I'm going to disable our volume builder. So we have our sphere. I'm going to add details on the geometry first. So for that, I could just add another displacer. I'm going to put it on the bottom, so it's going to happen after this one. Okay, on this displacer, we're going to add another noise. It's going to create those details here. I'm going to go to the noise and let's use something like the looker, which is going to give us more details. Then obviously I'm going to need to augment the segments a lot. That's why I wanted to have parametric shape. Okay, so here the red is because this is inside the sphere and so on. So it's problem of material. I will go to option and deactivate the material. Also to the display, use the quick shading so we can see something better like that. About the facets here, it's because we have our font tag. I'm going to uncheck everything, so it's going to smooth everything. Okay, so our noise is interesting, but it's too sharp. I'm just going to increase the scale until we're starting to have some details and not so much about those spikes here. Okay, so I could again increase the segment, or I could even use, for example, a subdivision surface. But I think with the segments we're fine. And on this displacement here, I will increase again the looker, so we have some subtle details like that. Okay. Now, if I activate again the volume builder and at start, we can see we already have a nicer cloud just using that. Okay. Now we're going to go a step further. So if we want to add even more details, we need to do it through the voxels. So how are we going to do that? We can use inside the volume builder using a field, and we have a perfect field for that. We can use, no, the field are here. We can use our random field. Okay, the random field, I'm going to put it inside the volume builder. So it's there. By default, if I hit render again, I won't see anything because our random field is a box inside there. And I can see it actually if I just uncheck our sphere. And now we can see our noise. So you can see it already has some kind of, well, it looks like a very, very bizarre cloud, but it works. And here using our random field, so I need to go there, random field, we can use some different type of noise and see how it looks. So for example, I could use here the gaseous cloud. Well, gaseous, it makes sense. And if I increase the scale, we're going to start to see some shape. Okay, and that's the kind of look I'm interested in. So let's go to our volume builder. I'm going to activate again our sphere. We see our sphere. And we still have the problem. We don't see our random field because it's a box. So I just need here creation space. Instead of using a box, I want to use the object below. And there we have our cloud with some details, but it still looks like crap because it's just on normal. So it's going to add the voxel and we're going to lose the nice fall off we had earlier. So we just need here to play with the mode. And obviously, if we use something like the min mode, it's going to subtract the effect. So actually, several modes are going to work. The min is going to work. The subtract is going to work. And that's already very interesting. And also the multiply. Okay, that makes different shape. It's up to you. It depends on the kind of noise and so on. The min works, the subtract works very well with our cloud because it creates that kind of shape. Okay. Now I have a new problem. Is that we have almost something which is too wispy. We have some nice detail here on the edges, so that's cool. But we don't have on the center of the cloud. It just looks wrong. Okay, because our noise has taken over everything. So we need to find a way to get back some detail at the center of the cloud, because actually a cloud is more dense inside than on the outside, on the outskirt. So how we can do that with Redshift, with the volume and so on. So we could reuse the same sphere, our same emitter, our same sphere, to put it back on top of it. That could work. So let's try that. I'm going to take our volume builder and we're going to actually our sphere. I'm going to duplicate the sphere. I'll put it just on the top, but the order doesn't count because you can just reorder it this way. So we have our new sphere and I will put it inside. And just because it made sense for me, I will put it there. Okay, so this is outside, let's say. This is the inside. And the inside, I'm going to decrease the radius. Okay, because this one is 100 centimeter. This one will be like 80 centimeter. Okay, and already you can see where I'm getting at. We have the inside of our cloud, and we have some kind of wisp here on the edges. So I will go to the volume builder here, and our inside here, I'm going just to change the maximum voxel fall off, obviously, because we want to have again the good fall off like that. And it's going to add a center on it. Okay, and then here the inside, instead of normal, I'm going to use max, which is going to blend everything together. And there we have our cloud. Okay, now what's very nice with that is everything is controlled by this random field. So I just need to a random field here to change a few settings to have a whole different look. I can just change the seed. Well, it doesn't seem to update. Well, it should change more than that. I'm a bit surprised, but I could change the scale. Let's go to 1600. Maybe the gaseous doesn't care about the seed. I don't know. I'm a bit surprised. I can change the scale, and you can see we have some details. We can go further than that again about the details, because I have been using here a 4 centimeter voxel size. That's pretty high actually. If we want to have something more detailed, I can just lower this value, or I can even increase it if I want to have something of a lower sample, which is going to be easier for your GPU and your computer. So let's try 6. See, it's 6. It still works pretty well. If it's going to be a cloud seen from very far, that will be just enough. We could even go to 8. And see, it works pretty well. And here at 10 centimeter, it's still okay. If you look at it from there, it looks good. And at 10 centimeter, I can tell you this is a very optimized cloud. It's okay. But if I go very close, it's a bit short. So I can go the other way and here decrease. So that's counterintuitive, because if you decrease the voxel size, you increase the quality. Okay, so if I go to 2 centimeter, we have much more details. I can go to 1 centimeter, and now it's getting some time to calculate, but we'll have even nicer detail here. And I could just go bonkers and try something like 0.5 or 0.1. I won't do it because it's I think that's already pretty good. And then again, I can change several stuff inside. I can take this displacer and this one, and this is the whole shape of the cloud, and I could change here and change our global scale. Let's go to, well, let's change the seed. So it's recalculating the 2 volume builder, and you have whole different shape in just one click. So I'm going to decrease actually the size and go back to 4 because it's already nice at 4. It will be much faster to calculate. So that's really fun, because with just a few clicks every time, you can change your kind of noise and have all different kind of clouds as you want. And of course, you can imagine if that works with a simple sphere, you can do it with any object. So that could be a text cloud very easily by just creating a text with the extrude and just put it there instead of the sphere. I'm sure we will have some tweakings to do, but it will work. And here it's already pretty nice with our sphere. And again, here with that random field, I can change a lot of stuff. I can change the type of noise to have some whole different results. So the gaseous is getting good results, but I found also that that worked pretty well with the notches. You see, we have more details, so I need to increase the scale. All the noises have different shape, different behavior. They're all interesting to try. So here we have a notches. The Luca gives some good results. It depends on here. It's not that interesting. Let's try another seed. See, we have this wisp here. It's pretty nice. We could try some other. We could even do some crazy stuff like the Voronoi. Well, not actually like the bugs. Not the mud bugs, mud noise. And I think I need to decrease. It's going to give us some kind of cubes. Well, because of my inside cloud, we can't really see it, but you can see here we have some sharp edges. It could be interesting. All the noises are interesting. The POXO is going to give us a lot of details. I'm going to increase the scale. And also, we could play with the remapping. So playing with the remapping, it's like we're going to decrease or try to work on the opacity, on the black and white value. So here on the contour, I just need to use the curve, for example, and we can see here. See if I increase, and like that, I have more wispy look on the side. If I just deactivate this cloud, we can see We could even use it just like that if we want to have some very narrow cloud. And here on the field, I guess I would just increase a lot the scale. Well, a lot, I guess. Let's go to 16,000. And here we could get the inside again, but the inside I'm going to decrease the size here to 60 or maybe 80. And we could even go further because our inside cloud is going to give us this shape. What I could do is create a new folder. So you can put stuff inside the folder. I'm going to put this one here. I'm going to use this one as Maxon, so we get back on our feet. And inside this folder, I could use some other filter here, like the range map. And the range map is going to allow me to change the voxel. So if I put a max output to 0.5, it's like adding a fall off to the edges. Still playing here with the whole stuff. So again, it's almost infinite. And I could use a different random field inside this folder to have this cloud. Well, just you have many possibilities. Stuff we could do also is I had some tests which were interesting. We could dissipate the cloud by just animating the value here on the random field because it's on subtract. If this random field I'm going to animate here on the remapping this value, at some point it's going to just disappear. So you see, like a cloud spawning up and then shrinking. So in order to really see that, I need to deactivate the inside, and we could create some stuff like that. And so that's really fun to play with it. I've been a bit obsessed with that subject for over a month, trying all kind of software. I mean, I'm pretty happy with the result I could obtain with just Cinema 4D, plain old Cinema 4D. And that's it for our cloud. So what we could do from there, we could create a whole cloudscape with different objects like that. That would be easy. You're just going to put that inside a cloner. It's going to work. Also, something you could do, because if you have especially low value here, if you are going to open a scene with several of those beasts, it's going to take a while to load. That's why my the main file I provided take some time to open, because it's had to calculate all the volume together. And so you can just freeze that state very easily if you go to your volume builder, file, and you're going to export, and you're going to export a volume. You can see here VDB. Selected only, so only this volume, and I'm going to export this volume to let's put it here on text, volume cloud. It's been exported. Now I could just hide everything, use instead the Redshift volume. I'm going to load what I've just created. So it's there. It's my whole mess of file. And I just forgot where I put it. Oh yeah, I put it in text folder. Yes. You see only 400K. That's pretty low. And now I can create a duplicate of this one, put it on the Redshift volume, And here just need the presets to change from volume builder to the Redshift volume builder. Okay, well, actually I could have just kept the same name, and now it's going to work just the same. The difference is now it doesn't need to calculate the stuff. It's going to be very memory efficient. So if I put that inside a cloner, I can already try just like that. And you see, it's almost instantaneous. I don't know if that's instantaneous. Yes, that's a word. And you could use also now some cloner to randomize everything, work with the scale, and obviously the rotation, and create some even more crazier cloud like that. And we could just go crazy with that and create a lot. I've made some tests with that. It works very well with a lot of clouds. I tried 1000 by 1000 and it went through using the Redshift volume. Okay, it won't work if you use just a volume builder. Okay, so that's it about the volume builder. As you can see, it's very nice to play with, and again, you can obtain much nicer results if you just don't have 1 hour to explain everything. It's really it's a good way to create clouds. So yes, I have time to show you the Xparticle way, which is going to give us even nicer cloud, I would say, but it's going to be a bit more difficult. So be advised, yes, it's going to get more complex, but let's go. So using Xparticles, I'm going to create a new project, and the starting point will be almost the same. So actually, I'm going to just recycle our outside. So Control C and Control V, that's something I really like with C4D. You can just copy paste stuff as much as you want. Now, this is going to be our base emitter. So let's use here our XP system. So I won't explain everything about Xparticle because it is just huge. Everything that's to be studied about that. I'm just going to show you the basic steps. So you need to use Explosia FX. It's going to give us a domain. I will put it a bit bigger than the cloud. Let's put the cloud in the utilities. On our cloud outside, I'm going to add a tag, which will be the XP source emitter, Explosia FX source. Okay, and on the tag here, I need to adjust a few settings. We don't want to play with fire. We just want to create smoke. So smoke to 100%, heat and fuel to 0. Okay, that makes sense because we just want to make smoke, and cloud is basically smoke. The pressure is the pressure at which the voxels are going to be created. So 10 is a bit too much. That works for fire. That doesn't work for smoke because it's going to push too much the smoke. So I'm just going to lower the pressure. Then on Explosia FX, here I'm going to, on the solver, let's try a voxel size of 6 centimeters. You don't need to have very much. So Explosia FX is going to work with that. Now on the simulation, I'm going to play with a few settings. I don't need very much gravity because cloud is going to stay in the air, obviously. I'm looking at some notes I've created because there are a lot of settings to change. So we have our smoke buoyancy. This is the buoyancy of the smoke. So we don't want to have a heavy smoke. So I'm just going to lower it a lot. Heat buoyancy, we don't care. Vorticity, 5% is fine enough. Turbulence strength, actually the turbulence radius, I'm going to increase it because you have a fairly large object. And then the most important settings will be here on the diffusion. The diffusion is going just to equalize the value for each of the voxel compared to the nearby voxel. So each voxel is going to take some value from its neighbor. And for a cloud, it's going to work very well because it's going to create some kind of fall off. So let's use smoke dissipation to the smoke diffusion to the maximum 100%. And we do need to use some dissipation, the smoke, because typically a cloud is going to dissipate. It's going to twirl and to just dissipate. So this is a dissipation, and let's try something like 0.2. I think it will be enough. Then we need to use some modifier. So the modifier is going to control the motion of the cloud. I will use a turbulence modifier. I'm going to use the default turbulence, but decrease the strength. We need to say to tell Explosia to use our cloud. So it's in the modifier. I'm going to just drag here the turbulence inside. So it's going to use it. And I think we're all set. So now I'm going to hide our cloud because we don't need to see. I'm going to hide it in the render again, and we just hit play, and we can see some voxel being created. And the voxel are going to evolve over the time because of our XP turbulence. So it's pretty slow, 3 frames per second, but we can see we have our clouds taking shape. So that's the downside of that. It's a simulation, so you have to be patient. You won't have instant result like with the volume. So here we're already fine, and we can again create our lighting. So sun and sky rig, the sun, let's go to the volume to the maximum. I'm going to add a volume material. So same workflow as with our volume cloud. I'm going to put that on the Explosia FX. And here on the channel, I'm going to tell him to use the Explosia FX smoke, obviously. And that's it. We can already hit render and see our cloud. And again, use here the scatter coefficient to have some nicer detail, maybe decrease the absorption coefficient. We have some kind of blocky voxels, so because we don't have the maximum fall off we had with the volume builder, we go to advanced and we can change here the density remap range, and you can lower the new max to have something more like that. See, it's going to create some kind of fall off and have a nicer result. And that's the basic of our cloud. To have now more details, we just need on Explosia FX here. You have the upres, so that's with the very last Xparticles, which has been released this summer. And the upres is just going to give us details while maintaining a low voxel size. So it's going to be faster to calculate, and we have the nice details of the upres with the voxel size of 3. So now I will go back again and we will launch it, and we can see we have already more details. It's going to add the details, so we'll have just to wait through to have some interesting results. Actually, I think I will go back and increase the radius maybe to 15. And I guess on the simulation, I will increase the turbulence radius of the whole voxel here to 3%. Okay. So now it's going to calculate. maybe I could answer some question because we just have to wait. I'm not sure I will have as good a result as my precedent test, but I'm looking at the question.
We had a couple of questions about working on an AMD system rather than a Windows system. In fact, it might be interesting just for you to share what's happening, what you use, because I think you've got a Threadripper and also you've got an RTX 3090 card on your setup, haven't you, Lionel?
Yeah, I have good equipment. Not everybody can have that, I know. So yes, I have the Threadripper. It's 16 cores, so it's pretty fast. 32 threads on in all. 64 gig of RAM. That's also important. And for the graphic card, I just bought recently RTX 3090, which is just a beast. It's so fast. It is so expensive also, but actually it's really good because you can work so much faster. It's a dream to work with because it's so fast. So yes, I have a very good setup.
It's interesting because I know you didn't have as fast a card before in the past, and I loved your philosophy that you previously shared about a certain number of seconds or minutes per frame, and if it was going over that, then you would redo the settings to make sure that you had enough time left in your schedule. So I just wondered how this new card has affected that philosophy.
Well, it didn't. I'd still have my 2 minutes cap. That's 2 minutes a frame maximum. I try to have like 1 minute, but 2 minutes is at top. And I do everything I can to have to be under 2 minutes. But with that card, I can put more stuff inside my scene. So I don't ever need a render farm, except when you have very heavy project. Recently, I did one with the whole forest, something very complicated, and even that was too much for my graphic card to be calculated in just one night. So I used render farm. But for that kind of stuff I'm showing, the whole animation I showed, it's only 4 hours of computing now. So it's very fast. I could launch 2 in the night if I wanted. The philosophy here is to have the rendering that can be done in just one night. And if it doesn't, I just try to find a way. So it's well, I learned 3D at the time where you didn't have those great render engine. It was really a pain to work with 3D. You had to wait for days sometimes. So I got obsessed with optimization to have the best possible result. And here is our cloud.
Just as a side comment on that, Glenn's mentioning about when you're using simulations and the trade-off with the faster processes rather than more cores. I think again, this is one of those it depends answers because it depends on what you're setting up.
Yes, when you're going to work with simulations, it's always going to be longer, more difficult to work with. Here, obviously, my cloud is heavier for the processor and everything, but you can see we have some interesting result we didn't have earlier. So here I'm working here with the scatter coefficient to have a different lighting, and you see we have interesting cloud we didn't have with the other method. And what's interesting is the way this cloud is going to evolve is much more realistic than the one with only with the volume, because the volume is just a noise. It's too mathematical. Here we're just mimicking the way cloud are really going to evolve. Okay, and this gives nicer results, but at the expense of more computing time, more settings, more tweaking. It was really tricky to have something interesting with like that, but I think that's pretty nice. That's I would say I'm happy with that. So just to wrap it up, if you want to keep that, you can use here just on the utilities. Here we can use the XP cache, which is going to create here the EFX format. You just change to OpenVDB. It's going to give you OpenVDB. You can use with Redshift, with Cinema 4D, just as you want. So it's very easy, and you will have animation, so you can have the whole forming of the cloud. Something interesting I found out also, if you just want to have a static noise, but static cloud, but just with the subtle movement, what I do is I just deactivate the turbulence. I'm going to take our cloud here. I'm going to the solver. I'm going to set a state. So I'm going to create an initial state. So that will be the frame one. And now it's just going to evolve through here our simulation, our turbulence radius, and here our turbulence radius on the upraise. So the whole shape is going to stay put, but we have those area here, which is going to dissipate and being replaced by other things. So we can just try a few frames. You will see now it doesn't move that much, but just ever so slightly, like a real cloud does. You see it just simply moving here. Like a cloud should do. You see it just moving a bit, and you just put that inside the cache, OpenVDB, and you can use it and put it in the cloner like I showed you earlier, and has some very interesting result. And actually this cloud was created using this method. This is a cloud created inside Xparticles. Then put that inside a cloner using the, and actually we have it here. So this is the final cloud. You can see this is a cloner with the volume loader, which is something else I don't have time to explain. But at the end, we have this beautiful cloud, which is very much detailed. So it's taking longer to compute. Maybe it won't on the viewport. Well, let's try on the RV. Ooh, something wrong. Well, that will be it, I guess. Yeah, it doesn't work anymore. That's too bad for an ending, but I don't know what's going on. So I guess that's too bad. Huh?
That's still a lot of great work and a really, really cool exercise. Thank you so much, Lionel.
Yeah, that doesn't work anymore. I'm sorry about that. Yeah, I hope that wasn't too fast.
No, I don't think so. I think that was like perfect. I mean, the videos online. Let's see. Do you by chance have the YouTube page, or should I show my screen?
Yeah, go ahead, show your screen. Huh?
Okay. Let's see, where we go. Share screen. Come on. Okay. Here we go. Can you see my screen okay?
Yes.
Okay, wonderful. So yeah, this recording is going to be online. So you can go to the Maxon training team YouTube page and you'll be able to see it there. Also yesterday's recording, if you missed it, is right there. And let's see, I also want to show you on the Maxon events page, all of the other webinars that we have coming up, including shooting for the grade, which started on Monday, and Ask the Trainer. So there's a lot of cool things coming up. So make sure you keep your eye on this page. And if you have any questions or requests or anything, you can email us at training@maxon.net. And thank you all for coming. Again, awesome job, Lionel. So excited to see anything that you do. It's just so wonderful. So thank you again, and thank you everybody for showing up. And with that, unless there's any final thing that you want to mention, I guess we'll call it a day.
Bye-bye. See you tomorrow.
Bye, everybody.